point in time when you need to ask questions, okay? Okay. So, you know, I understand what is dot any. Like, is there any, um, is it any, wait, there are a whole lot. Sometimes when you don't use them, you even forget. Which dot? No. Which dot? Main? Okay. But I can, okay, yeah, I can put any as well. So any is dot any. In other words, is any of these salaries any? Okay, so if is dot any will check whether whatever you are putting in is any, right? So you see that the first one is false, false, false. It means 10 is not any. But you see the last but one is what? It's true. It is any, right? Then this means any of the salaries any. So it's like English, right? You can answer this. This should be true, right? Isn't it? Yeah. Which I think I can put which as well. Which will, which is dot any will mean which of the salaries is any. So this, what do you expect? You expect to get the position of the person who did not what provide his salary response. So if you count from here, 1, 2, 3, 4, 5, 6. So it means that the sixth person is what did not provide his salary. Okay. So in the same way, for example, the matrices, the data frames as well, we can put is, okay, dot, then to ask questions on it. So for example, we can check is dot vector. In other words, is salary a vector? Can you give me what will happen? What will be the answer? Can you tell me what the answer will be? Is salary a
True,
vector?
true. Yes, please, a
Yeah,
vector.
it should be true. Yeah. Okay, so true. I can check whether it's a matrix by just saying not is dot what matrix. I mean, at this stage, you won't really use these kind of things, but sometimes if you are writing, so it tells you that it's false. Okay, so you remember. Okay, we will write a function now to, let's say you did one for computing correlation. Okay, so we are going to write a function to compute the correlation between things. Remember that correlation, you need two variables, right? Your
Yes,
x and
sir.
the y. Okay, so it is possible that I can write a function in which the argument that I'm taking in is just one, like a data frame, right? And then a data frame, then I extract the x and y, or I can just put in just x and y. Okay, so in that case, you can check if it is a vector because you need a matrix. Then you don't move on, or you tell the reader that okay, in this case, I need what? I need a matrix, not a vector, something like that. So then you need questions like: is this a matrix? Is it a data frame, and so forth. So here's the data frame: is dot data dot frame, is a list, is dot list, and so forth. So we can use is to precede any of these to check some of it. But the key thing is that the missing data is what any like that. Okay. Then we've also seen logicals. What are logicals? Logicals are the true or false. So R actually what recognizes true and false. Okay. So I can have a matrix or a vector. So I can ask let's say 3 people from the class, and the question is, will you vote or I want it to be definite, so I'll say, if it is, will you? Okay, you will vote, right? So if you won't vote in the next election, your answer will be what? False, right? The next one, if the person will vote is true, right? I also recognizes F as false and of course T as true. Okay, so I can do this if I, you see, it recognizes them. So when I display it, everything is on in the entire spelling, right? Like false, true, and so forth. So this is logical. If you come to your over here, you will vote. That will be a vector. So let's come here. What do you see? It says logic, right? By weight is numeric, right? And then you see religion is character. So those are the data types that you see in there. Okay. What else? We've talked about this, characters, missing data, logicals. We have dates, stroke time. Okay. So R also recognizes time and date. So for example, you can type sys.time. Let's come down. So dates, stroke time. Okay. So sometimes when you are doing simulations, you want to know the time. So sys.time, I can display this, and R displays the time and date for you on the screen. You can also do sys.date, right? Okay. Right, so the date is given. Okay, so I can actually have a vector which is what? Date as well. So you can convert. I also did not talk about as. So the same way we use is to ask a question, you can also use as to coerce. We call it coercion. Okay, so I can coerce something to date, a data frame, or a matrix, or whatever, right? Okay, once there's as, it means converted to, that in a layman. So date, you say as.date. Okay, if you want to see how this can be done, okay, you can also do question mark, and then you come to here, it will tell you that as.date. So you take X, you can get a format of the dates, okay? That is year, month. If you look over here, try the format. The format, year, month, or day, okay? Or year if you want it to be slash month, which means you can have other format, like the way we write our date. We write the day first, and the month, and the year. In some cases, they will write it for year, month, and day, okay, and so forth. So we can also have dates in R, and that's why R is able to handle time series data. So if you have a time series data, you don't need to list all the time and so forth, but you can just so you can take an example here. If you go down here, there's an example like this. You can copy, bring it here, and run it to see how this is. So you see here, X is like a vector. 1 January 1960, 2 January 1960, 31st March 1960, and so forth. So this, when you do it, definitely will be a character. If you go here, you see that this is a character X. X is our character 4. You see it's there. But now we can then convert it to what? Date. So this is what? Day. Then you have what? Month, and then what? Year. Okay, so if you do it this way, now Z is what? Date. You get it, and you can display Z and so forth. 1960, this and so forth. So I mean, I have so many data types. Okay, and then lastly we can talk about factors. Factor. You remember in the basic statistics, you have when you have qualitative data, the scale of measurement will be what? Nominal or what? Ordinal, right? So R uses factor to help you note what? Nominal, ordinal scales. Okay, good. So if you want to get do a factor, you need what? You can go to help files of factor and so forth. So we have factor, it is in the base package. Okay, look at this one. Is dot factor, is dot ordered factor, as the factor, then it means you want to convert it to a factor. So whatever you want to do, you take it at X. Usually we take characters, and then it has levels, okay, and then label, okay. Usually labels are considered as the levels unless otherwise stated. Okay, so this date, the date X, I can convert it into a vector. Okay, now how do I do so? The X, right? I can say factor. Remember that X, if I display X, it is like this. Now let me pass X through a factor. You see, now it rises, and then it tells you it has 4 levels, right? And so forth. You see this ordered. If I want to get it to be what? Under the ordinal scale, I will say ordered is true. Okay. Now, you see 1st January, 2nd January, 3rd March, and so forth, and 30th July. You see now it is ordered. So what it's saying is that 1st January is less than 2nd January, and it's up to what? Less than what? 31st March 1960. Okay. Now you can arrange them. So for example, if we have a grading system, then we need to use factor to do it, because then we can order it. Okay, so that we know that A is better than B and C and so forth. So that's it with these data types. Okay. Any questions so far? Okay. So I will send you this book. I don't know whether did I show you how you get the books from the Annex Archive?
Annex Archive.
Yeah. So please download the R in Action. You can have all these things nicely treated in there. And of course, you can also check from the YouTube page. The data structures, if you watch the video, you will see all these data structures and data type and so forth, so that we don't waste so much time on it. Okay. Now,
Yes, sir.
once, if you have any question, you can ask. Otherwise, we move on. Okay. Now, how do we get data into R? Did we treat that?
No, please.
Okay. So, importing and exporting data into R. Okay, good. Now, then I need to do that before descriptive statistics. Okay. So now it's like, because we have done the, what do we call it, the data structures, we know how to create. If I, let's say, give you data on students in this class, and I want you to put it into R, you may use a data frame to construct such a structure for the data that you collected. Okay, but what if you go to an organization and then they give you what do we call it, a data set, and you want to you want to work on it? Do you have to now retype everything? No. I can read several forms of data. It can read text, it can read Excel, Excel in CSV or in .slx, okay, and then what do we call it? Even other programs like SPSS, SAS, and what have you, Python, and so forth. Okay, so let's see how we can read data into. Now, if you look over here in your environment, you will see this sign. If I do this, it will show. Look, you see this import data, right? Now here you see test, which is like the notepad you have on your computer. You can also use the same test but using a package readout. So this is from the base package. This is from readout. Okay. You can also read your data or import data through Excel format, right? SPSS, SAS, and from Stata. Okay. There are other packages that you can install to get other languages, like maybe Python, or if you have it in MATLAB, or if you have it in ITSM and so forth, you should be, or Minitab and so forth, you should be able to read it into R. So here we will just look at test and then Excel. Okay. Now, so let's see. Have you installed the package insurance data? Not yet.
I think you did it the last time.
You okay? So or otherwise, let's okay. So if you have done that, then let's see. Or there's okay, mass. Okay, let's go to mass. I think there's some data on insurance, if my memory serves me right. Insurance. No. I need to come here. Yes. Okay. Okay. So look over here. There's insurance, right? Okay. So make sure package mass is ticked, and then get this insurance. Insurance package, nicely done, like this. Okay. Then you can copy. You copy, so Control C, and then you can paste it in or what is the easiest way around? You have a WhatsApp group, right?
Yes, sir.
Okay, so kindly add my number, then I can send you a data now.
Sir, please, can you send it to Senna?
Okay, all right, that's also easy. So I'll
Yes,
send you
sir.
so that we don't waste our time creating all this. Where do I get some of this data set? Okay, okay. I'll send it now. Let me go here. Let's see. Just a moment. Why is this slow like that? Insurance. Okay. Okay. Yeah, this is okay. But does it come like a test? In okay, it's like a CSV. Okay, so you can send this to me as well, the link, so that we can also read it straight away. It's so slow. Okay. So many things. Okay, so what we are going to do is that we are going to read from test. You can also read from, let's say, online, right? When you have an online data online. So, just a moment. Okay, good. Okay, so Senna, I've sent you some data. You can make it available. Then everybody should have it on their. Okay, send that one to your group. Okay, I'm coming. Let me forward it to you too. So this data is in R, but that's what I was going to do. What was I going to do? Okay, yeah. To create it like the way, but it will waste our time. So I have done it already. Okay, so please get access to the data. It's called the anorexia data. So I'll display that data on the screen. It's in the mass package as well. It is called anorexia, like this. Okay, so let me see. Okay, so this is how the data looks like. It's what? A data frame that has 72 rows and 3 columns. It's weight change data for what? Young female anorexia patient. So the people were not eating or they have some eating disorders. And then they gave them some treatment. So your weight before is measured, your weight after is measured. Right? So we are assuming that this data, this is the same data that has been given to you in the form of test, in the form of what? It's the CSV file. I sent you 3. So whichever one it is, you should be in a position to read them. Okay. So 2020. Just a moment, I'm getting my own. Okay, 100 up to 6. Okay. Okay, so let's assume that I want to read the data that I gave you. I'll go to import, so you get it whether it's on downloads or so. You first go to import. I'm assuming we want the test one, so I'll use this, right? I click on this, then it opens my folder. I just have to navigate to where that data set is. Okay, so my own is in up to 602. I look for 2020, and the data is this. It's called anno, right? So I just click on it, and then, but this is the test. I use a test, so I cannot now go and use Excel, right? You see, this one is Microsoft Excel. This one is what? Anorexia. The other one is what? It is also Excel, but it is in what? Comma separated file. Now, when I put it on it, you see the file size. Look at the comma separated file. It's 1.27 kilobyte. It gives you, it's the same data, right? But when you go to that of Excel, it gives you 11.3, which means if you have a data in Excel and you want to store it, it is better you store it in a CSV file. In other words, it will reduce the size by almost like, in this case, about 6 times, right? It will just take 1/6 of the size you need. So the CSV is just like your a test document. Okay, in terms of size. Okay, so I do it like this. So import, and then it brings me to this file. So please, you can do so when you reach this stage. You can alert me. So first of all, you go to what? Import data. Note where the folder in which the data is stored, right? And then what do? You click on import data in R. I can go back. You go to environment. There is import data, but this is a test data. So you go to test base, and then you navigate to where this thing is, right? Where the folder is, okay, or where you've stored your data. So mine is here. It is this one, the test. So I click on it, I get this. Okay, I can change the name here. So I can say this is an anorexia test, which means it signifies that this is the one I read from what? The test document. So I can scroll down here. I checked. It says what? This is what it is inputting, the input file, but it will give us what? An output, which is what? A data frame. So I just click import, and there it is. So anorexia.test has now been presented imported into R. Any question on this? You can go through the same process to import the Excel one. So Excel, you browse as well. Okay, navigate to where the data is stored. Okay, and then what do? This one is the Excel one. You just click on it. In the first time that you do this, you need internet because it needs to read, it needs to make use of that package, which is called what? Read Excel. Okay, and whatever we are doing, this is the counterpart code that will give you that. That will give you the same results. Okay, so here too, you can change the name here. Anorexia Excel. Okay. And then you click import. There it is. So you see it's the same thing. Whichever way we look at it, we can easily get it at that. Okay. Any question?
Doc, please, so with the CSV, which of them will you select?
Yeah, so the CSV, you can't read it straight away from here, but we can use a function to do it, okay? So there's a function called read.csv. But before then, you must set your working directory to the folder. It makes it easier. So set the working directory. Because I am using up to 604, okay, it means I will need the data in there. So I just set my working directory to that file or that folder. So I have to go and get it means that when you download it, your data should be in what? In the folder your R resides in. Okay. Then it makes it easier because then you just need to give the name, and then it will read it from it. So I am coming. I have to. I used to see only the R. Sorry, the R Studio page.
Yes, please.
Oh, okay. You don't see any folder opening up. Do you see any folder?
No, we are seeing the interface of R.
Okay. A moment. Okay. So what you need to do is copy the data into the folder you have. Remember we did create a folder, right? Oh, how come I don't have? Oh yeah, it's here. Okay. So have you done that? Put it in your folder. Then make sure that you set your working directory to that folder. It makes it easier, because other than that you have to add a file path, which you don't want to do now. Okay. So this is what I mean. Let me maybe share my screen again. Okay, so so let me share my folder screen and then you see. Okay, so this is what I mean, that you should get, you see, Act 2602 to 2024, but I've placed this one over there, and in R, remember that I've done this. So when you look on my console at the top here, you see, if I click over here, it tells me all the, so this is the Excel folder. This is the Excel file, we have read it. This is, oh, sorry, you are not seeing. Yes, I have to be alternative before between them and, okay. So this is what I mean. So you see that folder. Now in R, remember that I set my working directory by saying session wherever my this thing is, source file, put it there. So that's the source file, it's in the active. So if I look in there, what do I have? I have that data set in there. Is that this one that we want to read, isn't it? Anno.csv. So what do? There's I can then write this anorexia CSV. Okay. Then I'll do read.csv. So maybe before then, let's look at what read. You can, the general one is read.table. So instead of CSV, we can also use .table. They are all the same family of file. So read.table, and then we have variants of them, read.csv and so forth. So all I need is just this, right? The first two are usually okay, but you can explore others, other arguments. Okay, so you can explore other arguments like separator. So you may have a data set in which commas separate them, and so for them quote and what have you. So you can check it, down there. But in this case, we just need this one. So what do? The file, I need a file name there in, you see, you remember the file name. If you go here, it's called anno.csv. So the same thing like this. Then header. The header is, does it have a header? Yes. Go here and see. You see it has number, treat, pre-weight. That's the header. So that the header is what? Is an argument, a logical argument. In this case, it should be true. If you say false, then it will make number and treat as part of the data. And in that case, it will render pre-weight, post-weight, and all of them as what? As characters. Because, the number combining with what? Character will reduce it to the lowest, lower type, not structure, but type. Lower data type, which is in this case character. So I can do this and run. Okay, so I ran it, there was no error, so I can come to my here to check, right? This is it, anorexia. I click on it, I have it. It's the same data read easily into R. So that's how you read data of different scenarios. Okay. or types, different data types in there. Okay. This thing, I'm not sure. Is there a mistake? Sorry, it's not you, eh? So please practice. I'm waiting. If you have any question, you let me know. Sometimes, let me. Yeah, sometimes it does. I don't know whether because I did it the previous day and it is recognizing it. Okay. Okay.
And I seen him before too. It's an deadline.
Last time Dr. Okram received some accounts.
Let me see. I think maybe
I think
Ashensi has some. Let me check for you. Because this thing shouldn't maximum 2 hours, and it's the whole day. So I don't know whether I should even, but. The mistake I did was that I also removed the other one that I did. Please, are you okay? If you have any question, you can ask.
We are good, sir.
Okay, so we can move on. So that's it. Now, if you want to read the data, to online, you can also, instead of the file, so I'm not going to go through this. Remember that here I said file, right? I could have also put in a URL over here. In other words, if you go to the data, you copy the file path and put it there. It will also read it. So that's another way. So you can either use I can go to help. You can use the read.table, which is what? The universal one. Okay. This one. So file, and then the header is through. You use it like that. Okay. Any question? So I'll send you some data set in GitHub that you can play along with, be able to read it from online. Okay. So now I'm assuming that you have the data, and then you want to get some descriptive statistics. Well, so descriptive statistics, we have graphical and let's say numeric, or how should I graphic, the correct thing. Okay, numeric, use generical. Okay, numerical form, graphical or numerical form. Okay, so what do I mean by this? Well, if I have a data set, I may be able, I may want to know some descriptive statistics like measures of averages or measures of central tendencies. Okay, and some other statistics like maximum, minimum, and so forth. Okay, so if you take a look at the anorexia data, so let's assume I have the anorexia CV. This is a data frame, so I can put the $sign there. It will display what? All the content. In other words, all the variables. So the pre-weight is this. These are the pre-weights. Okay. So I can find the average, the mean of the pre-weight is 82. I can find the median. That's also 82.3 and so forth, right? Okay, but I may need more. Have I asked you to install the package psych?
No, sir, if not.
Okay, so there's this package called psych. You can install it. psych like this. The first one, like psychology.
Okay.
Yeah,
Like
so
psych your mind.
yes, so just go to install packages and then type psych and then install. So like this, and then you click on install. And of course it will go online. I have it already, so there's no need. If I click on it, this how I mean, the package was successfully, even though it's there already, it's still downloaded it. So I then come to packages. Okay, I can search for psych, and then I click on it. Okay, why are we doing this? Well, psych has what do we call it? A function called describe. So describe says descriptive statistics useful for psychometrics, but not for psychometrics alone. It can be anything. It can be actuarial and statistics or what have you. Okay, so it may not necessarily be. You want the key? So, thank you. So it can be any of those.
Yes, we can hear you. We can hear you.
You were not hearing me. Okay, so we want to use describe. So instead of summary, summary gave us some. Let me rerun it again. Summary gave us minimum, first quarter, median, mean, third quarter, maximum, right? But I may be interested in getting more descriptive statistics. So describe, which is in psych package, you must have psych, you must take it to have access to that function. So you see this one, it gives us the n, the number of observations. We did not get it in summary. It gives us the mean, it gives us the standard deviation, it gives us the median, it gives us the trimmed mean. What is trimmed mean? A trimmed mean means, remember in basic statistics, we have that the mean is affected by what? Extreme values, okay? So in the trim mean, you cut off the top order statistics and the percentage of what? The lower order statistics. Okay, so if we trimmed off by 5%, it means that 2.5% of the top order statistics will be taken out of the data. 2.5% of the lower order statistics will also be taken out. And then we have the 95% of the middle part. And then we find the average. So that's what we mean by trimmed. This one is the median absolute deviation. Then the minimum value is there. The maximum value is there. The range, which is the maximum minus the minimum, is there. Then more important, you have skewness, you have ketosis, you have standard error. No, I don't need. You can give it to Prof. Okay. Is everybody okay? So that's it. So what this means is that you have to look around for functions in packages. If they have it, you use it. You don't have to reinvent any view. And you can go in and adapt the function to suit what you want to do, which you will do pretty soon. Okay, so that's it with descriptive statistics. Okay, now let me see. I can also add the post weight, right? I hope it works. But I can add a post weight and run it. Okay, it didn't. But what I can do is that I want to get those two. You can actually put a data frame here. Okay, so I want to do this. You remember the data, the first two values are what? Look at this one. I want to get the descriptive statistics for pre-weight and post-weight. So it means that number and treatment, these are, the number doesn't really, it's just numbering the individual, so it's not needed. Treatment too is categorical data, so I can't be finding averages of it, right? Okay, so all I need is just these two, pre-weight and post-weight. So how do I select it? Well, I can count the number of columns, 1, 2, okay? So it means column 3 and 4, right, is what I need. Okay, so two ways of getting it. I can state that take out 1 and 2, which means I'll negate them. If I do this and I run just this part, you see you get -1, -2. So what this means is that, remember, this is also a data frame. So I leave before the comma, which means every row should be selected, right? But I want to deselect the first and second row. So this will be the same as doing this as well. So I will rather provide the columns that I need, right? So that is easy. I can say 3 to 4, if you remember. Okay. So it means take 3 and 4. So whichever one I use, it will be the same results. Okay. What do I want to do here? Look. Let me expand this. So what I want to do is that he's not picking. So I think you can go. What I'll do is that I will. Okay, check for me if he is there. Let him check if he is there. So if he's there, tell him that I want to speak to him. I'll do it and submit it for them tomorrow. His guy is there, then he should be around. I'm sure by tomorrow this would have come. I'll also ask Eric to do it once I get it. So I think you can go. You can go, yeah. Yeah. I'll send it. Once I get it, I'll just email it to Naughty. Okay. Sorry for the inconvenience, but these machines sometimes. Okay. Yeah. Okay. So that's it. But the key thing is that here. Okay, thank you. Yeah. Here, all I'm saying is that use every anorexia one, okay, but only the third and fourth. It is the same as taking out the first and second one, right? Okay. So if I run this, I get the same results. I wanted them to be on the same line, so I'll rerun it again like this. Okay. So what have I done? Okay, the describe also gives us another. Please, can you hear me?
Yes, sir, we can hear you.
Okay. You should just interject, as I said, if you want to ask a question. What this tells us is that describe can take a data frame, right? When it takes a data frame, each column, it will just be what? Calculating what? The descriptive statistics for each column. That's what I've been done. So if you look at the first one, that is what? Pre-weight, right? And then the second one is what? Post-weight. So the variables are 1 and 2. Of course, they are the same, 72, 72. The mean, you see the mean of the pre-weight is less than what? The post-weight. Which means the people were actually responding to the treatment. But we don't know yet whether that difference is significant. If we want to do this, we must use a test of hypothesis, right, to do so. Which means we are checking whether the pre-weight of the same people that were introduced into the programs are different, and this and is this quite significant, right? So that's a sort of
Hello, Heidi.
So in this case, what kind of test can we use? This is elementary statistics. You have 72 people, you take their weight before, and then you enroll them on a program, and then you take their weights after. You want to check whether the program is successful. What kind of hypothesis test will you do? So this is a question for all of you.
So I think we can use the t-test.
Which of them?
T-test.
You must describe it further.
Okay, so we want to find whether the two are equal.
Which two are equal? You have weight before and weight after. Yes.
This is for per data.
Yeah, this is per data. That's what I wanted to hear. You see, this one, they are the same people. The unit of measurements are the same. You take the first person, you take measurement before and after. Okay? If it is independent test, then it means I can just take some people and then measure their weight. Then I go to maybe another class, I take another set of people, I measure their weight. And then I want to check whether the weight of, let's say, class 1 and class 2 are different. That one, I can even afford to let the sample size be different. So this may be 72, this one may be 50. So you can compare them, but that's independent test. Okay, so he is right. This is what we call dependent or paired t-test. Okay, so that please take note of that. Okay, all right. So the mean, we have the standard deviation and so forth. So what is the essence of this? It gives you a bird's eye view of the statistics, the numerical statistics on this, right? If you look at the data, this one is all skewed to the left, right? This one is all positively skewed or skewed to the right. Okay, and then ketosis and so forth. Okay, any question on this? So this is quite an important statistics that you can use later on. So then graphical.
Yeah.
Do you need to ask question? Okay. Otherwise, let's look at some graphical concepts. Okay. There are videos, so I'm going to be very brief. I just want to touch on the important aspect that you need. Okay. So remember that we said that data can be quantitative and qualitative, right? So when we have qualitative data, what kind of graphs can we use to display them? Please mention some graphical charts that you can use to describe qualitative data. So for example, I give you gender of people, male and female, or the religion of people that we just saw, and you want to describe them with graphs. What kind of graphs can you use?
So we can use bar charts or pie charts.
Okay, so we can use pie charts, pie or bar charts. Okay, so that's it. And now, how do we use it? Well, okay, so how do you construct a pie chart? If I were to give you data, this 10 people, then this is male, female, male, female. How are you going to construct a pie chart for it?
So please, you use a pie function.
No, I mean if I give it to you using your pen and paper, how are you going to construct the pie chart? I give you 10 people, and then I say their gender, male, female, male, and so forth. So I give you that raw data. How are you going to construct?
So you find the percentage.
Oh, okay.
Of the
So
you find percentage.
Yes.
Okay, of male and female.
Mm-hmm.
Okay, and then what
Yes,
next?
please.
If you find, so you got 60 and 40%, how are you going to plot your pie chart now?
so you can draw.
You can draw
Okay,
it.
Richmond, comment.
You multiply a percentage by 360 to get
Good.
the angle
Okay,
for
good,
each.
good. So what you, first of all, but it is important that you talk about the percentage or the proportion. How do you get a proportion? If I gave you the so male, female, male, maybe female, the next person is female, the next person is male, and so forth. How are you going to get the proportions?
So the number of male over the total number.
Good. But when you were doing it way back, what were you doing? Were you finding just the number of males? You were doing some table, right?
Yes.
What is it called? Table. Frequency table, isn't it? Good. So yes, the concept in R is the same. So when we give you, let's say, religion, okay, like this, okay, you cannot just plot it like that. You need a table. So in R, we also can table this. If you table it, it means you want a frequency table. So it tells you that Christians, they are 2, Muslim 1, other 1, traditionalist 1. Is everybody okay? So,
yes, please.
Yes. Just a moment. Yes. Are you at the office? Okay. I am sending you a student work. Can you check the plagiarism index for me? I've tried on Sakai, but the whole day it's not giving me report. So you can try, and then if you have other, if you have the Ashensi one too that you can use, you use it for. Submit it. Okay. So let me send it to you. No, okay, thanks. Okay, sorry. Okay, sorry for the interruption. Okay, so we do that. You know the proportions, I can also find it, right? As the tables, because this table gives me a frequency table. So I can find the sum. How many are they? So the sum, this will sum 5, isn't it? There are 5 people. So if I do this, I get your percentages, right? Okay, so, I mean, whatever we were doing on paper, you can do it as well. Okay, over here. So in R, you need a table, okay? It can be this, okay, so this is, this actually is relative frequency, right? Relative frequency table. Okay. So if you want to do this, you want to create a pie chart, you need to go through that. So if you don't table, you won't be able to create your pie chart. So the function to create the pie chart is pi, as someone said earlier. But before that, you need a table. And that table may be relative frequency or frequency. So the frequency one will just be this one. Will just be that. So frequency. And then in that case, I do pi. And then I just put in what? Frequency. Okay. All right. So it's the same thing. Okay. It doesn't matter which one. Now remember that this, you see the pie chart is so small within that place. Okay, I can reduce the size by using what we call the par function. Then I need to get the margins. We call it MAR, margins. Okay, then C. So the C, I'm counting from down here, 1, 2, 3, 4. So it's a vector of 4. So I can just put 1, 1, 1 over there because this is a pie chart. I don't need the sizes to create anything. So you see now it pops up and it becomes a bit bigger for you to do it. Okay. So that's the trick as well when you are doing this. But if it is a histogram and so forth, because you need the x axis and y axis labeled, you cannot be using 1, 1, 1. So in that case, I'll be using, let's say, 4, 4 to give me like 4 inches or so. Yeah, so you see, then you can write on those sections. Okay, so that's it with pie chart. Then you talk about bar charts. For bar chart, you use bar plots, right? Similarly, in that case as well, you need what? You need a frequency. Okay, so height, you need a frequency for it. Okay, so let's see. So the bar plot is like this. Okay, there are so many things. There's a video on this. So as I said, I'll be brief, but you can go and watch the video and get all the other. I'll just comment on them, and you see. So that's it for the bar. We can color it, right? We can color it. So color is equal to, let's say, 1 to 4, because there are 4 bars. You get it like that. Okay. The color, we can even select it randomly from the rainbow colors. Okay, so that's how flexible R is. Rainbow. Okay, so choose 4 colors from the rainbow. It means those will be random colors. So whenever I do it, I'll get different colors. Okay, so I did not sample, so I'm getting this. These are the first rainbow color, but you can sample numbers as well, and you get different results each time you do it. Okay, so that's it. And of course, we can label it if you want to label. So the S label will be what? Religion, right? Religion. Oh. Yeah, I need to put it in quotation marks so I can rerun this. You see now religion is there. Then what about the Y label? We need something for it. Y label will be what? In this case, it is what? Relative frequency. Relative frequency. Okay. So that's it. Any question? Any question?
No question, sir.
Okay, so yeah, so this actually is not relative, or even though I use relative, look at it, because we cannot get 2 in relative frequency. What did I use for the frequency? It's just the frequency, yeah. So 1, but because you have 4 bars, it does it like that. But if I want relative frequency, I must use either that or use there's a if you come here, there's a I think that should be histogram rather. So here, if you want to do it, you can do it. But in histogram, we can get relative frequency. I need to search through this. I haven't. You see that all these arguments, I think density, yeah. You can use density is true. Let me put density is true and then see. Yeah, that should give us the relative frequency, which true. Let's see. Okay, good. Oh no, still it didn't. Okay, so let me check what density is here. A vector giving density of shading lines. No, it's not. It's not it. So yeah, so in this case, I just have to use a relative frequency vector. But when we get to histogram, we don't need to do that. Once I have the frequency, that is enough for me to do whatever I want to do. Okay, so here, if I want it in, you see this one, none of them is above 1. So this one is a probability, so you don't expect any of them to be above 1. Okay, but I needed to use relative frequency. So we'll talk about histogram now. You realize that we don't need to be creating relative frequency. We can just get it straight away from our frequencies. Okay. Any question? So I can delete this density out and run this, and then you get your colors like that. Okay. So, but that's relative. If I take this one off, I get my frequency, and that is done. Okay. So, for example, remember the anorexia data, right? Okay. So what we can do is that we can, that one is not even encouraging, or it's not nice, because we have the same number of observations. Let's look at the insurance to see if we have something to demonstrate this. Okay, so the insurance, I think age group are all categorical variables. So look at age groups. So the groups is an ordered factor. Factors are quantitative variable. So I can table group. Are you with me? I can table insurance. Oh, sorry. Group. Okay. So if I do that, oh, that's also 16, 16, 16. So when you plot it, it won't really, give you anything better. But I can try it and tell you. So these are some of the things you do when you are doing data analysis. So, for example, in your thesis, right, or your project work, let's say you have this group of insurance people, then you plot this. So let's say here we say group, and then we have frequency, not relative frequency. So you do this. Object group. Oh, I did not run this. Okay, there it is. There's no need to put this plot in your thesis. There's no need. Who can tell me why?
Dog, because there's no need.
Oh, this one you are just using my own word to answer me. Why is this? Why? I want the reason behind it.
So it doesn't give any pictorial information about the data we have. So we can just state that maybe all of them are 15. Good. It doesn't show the dynamics of the data set.
Yes, it is equal. So this one, a sentence is okay to tell the reader that all of them, the groups were the same. That's all. So that's it. So there's no need to put this thing over there. As soon as we see that you put this one, then we know that you don't know what you are doing. So don't be like that. Okay, so we can go back and check. Yeah, so you just said we had equal number of what? Observations from this group as well as the other group. Let me look at, okay, so we did group. Let's look at age and see, maybe age will be different. Let's assume I want to take out this and replace it with age. Oh, sorry. Age. Let's see the age group. You see, that's also 16, 16, 16. So it's of no use, right? So this is not a good thing to do, and so forth. So that was just by the way to let you know that it's not every time that a graph is needed, right? Okay. So we can move on to quantitative data. When we have quantitative data, there are so many graphs that we can use. The first one we are talking about is a histogram. So in now we use hist to create a histogram. Right. Okay. So hist It's like this. So it also has so many arguments. It is up to you to explore. As I said, all the arguments, these are all arguments that you can use. But when you come down here, it will tell you all what these arguments are about. The frequency. If the frequency is false, it means that you are using relative frequency and so forth. Yes, hello. Yeah, hello. I'm teaching. Maybe try the interview. Okay, all right, good. So that's it with histogram. So if I want to do this, I want to plot a histogram. Okay, so for example, just now we saw this data. So let's say we want to see, this is quantitative, right? The holders. Okay, we can go ahead and check what the holders mean. But the claims are also quantitative. Okay, so we can get a histogram of the claims. So to do that, we just use histogram. Okay, and then I just copy this. Stages. I don't need that. Just use my frequency. I need this. I want to show you something. Okay, so now I'm going to call insurance. Good. Right? And then I select what? Claims, right? Okay, so the frequency is now, let's see, this is how it looks like. Okay. Look at the frequency. Now, if I say this is false, do you see what happened? So this is what I was talking about. So this is a probability. Later on, you see, we will be doing this. Let me share this screen and caution you here before we get there. So I'm going to unshare my screen. No, I want to share a new screen. Share the whiteboard. Okay, please, do you see my whiteboard? Do you
Yes,
see?
sir, we
Okay,
can see.
good. Okay, so you've seen this before. Oh, what is this? Next, skip. Okay.
No, sir.
You can't see the whiteboard.
No, sir.
Oh, are you using your phone?
Sir, we can see. It is very clear.
Okay.
I think those
Okay,
using
sir.
their phones can
Yes,
see, because I
think
also
if you are
can't
using
see.
your phone there, you can see. Okay, but we are recording, so you've seen this graph, right? I need a new. Where's this thing? Oh, where's my? Oh, it has fallen down. No. Unless I use my hand to draw. Oh, okay, it's okay. I can. Okay, you've seen this. So, for example, I can do this histogram. Okay, then I want to fit a distribution to it. You've seen this before.
Yes.
Good.
Just yesterday.
Okay, so later on, we will be, let's say this may be claims. The whole thing may be claims, right? So let's say I have claims, and then I have a histogram for these claims. Oh, sorry, my histogram is not that good. Okay, but don't mind me. Yes. Okay, so this is claims, and I want to fit a distribution to it. Okay, I would like to check maybe several distributions. I want to check which one actually fits them well, and so forth, right? Okay, now if this is frequency and you have, let's say, 10, okay, this place is maybe 6, and then 2, and 0. There's no way a probability can be 6, right? The frequency or relative frequency. Okay, so when you want to do that, when you are plotting a histogram, it must be, this place must be the relative frequency, which means the highest point will be what? 1. Okay, so whatever you have here, this same graph can be done this way, but the highest point is what? 1, because a probability cannot go beyond what? 1. Okay, so that's what I wanted you to draw your attention to. Okay, any question on this?
Sir, please, it is well noted.
Okay, all right, so let's move on. Let me, and then we can quickly close now.
Close. You're getting tired.
It's not easy. The way you are doing, there's a problem. Okay, so I mean, after a histogram, you can get box plots, right? You know box plots. Box plots. So before then, what can you say about the what comment can you make about the histogram we have over here? So I don't want to see this. It's not also good to have this, right? Insurance, $ claims, histogram of insurance. So first of all, I'm taking the main title off. So I put main inside, and then I put an empty. So now you see, you don't see it, right? It's gone. Then down here, I don't want to see insurance, $ claims. So please take note of it. If I give you an assignment and you do that, then I know you did not attend the class or you did not pay attention. Claims. So I do this again. There, you see it has taken it off. Right. Okay. So that's it. That's how you do. You present your histogram. Nicely done. If you want to color them, color. Right. You look at the number of bars, and then you can select either randomly or or recycle them. Okay, so that's it if you want to. But now box plot. Okay. Before then, can you comment on the distribution of claims? If you have this, how are you going to comment on it? No one.
So the distribution is skewed to the right. Hey, to the left.
What is left and what is right? When we say skewed to the left, what do we mean? In practice, how are you going to explain this? So if you read the claims, I think in this case the number of if we go back to what does the health files, what does it say? Number of car insurance claims. Okay, so the claims are number of claims, so it is not actually amount but the number. Okay, so you have holders, and then some of them will claim, some will not claim, right? So the number, so you realize that if you check the plot, between, let's say, 0 to 50, most of them, the numbers were between what? 0 to 50. Then only a few were above, let's say, 300. Okay, so this is skewed to the right. You have the longest tail to the right, which means you do not have, larger numbers. In other words, the larger numbers are rare. They occur less frequently. That's why their probability is very low compared to those between, let's say, 0 to 100. Is everybody okay with this?
Well noted.
Okay. So then let me end here with box plot, and then so box plot, you see, can whatever a histogram does, box plot can give you the same information. Okay, so box plot, it produces a box and whisker plot. Okay, you can actually put in a data frame, or you can put a formula, and it will get you all those graphs. Okay, so here we can do a box plot. Our X is equal to what? Insurance claims. Right. So this is depicting the same information that the box plot gave us. Oh, sorry, the histogram gave us. So you see most of the values were what? Below 100, right? So you see that the box is within there. Then these are outliers, if you remember from your basic statistics. The circles are what? Outliers. So here, if you draw your graph from down there up to here, the longer tail will be what? Towards the larger value. So we say it is what? Positively skewed, or skewed to the right. Okay. Similarly, here you can color, right? Okay, so color maybe 3. And so because it's just one box, it gives you green. Okay. Then for the box plot, you see the insurance data. I have, if I run this, I have the data according to, let's say, here is what? The districts, right? If I want to know the distribution of the claims per the district, I can do so as well. Okay, what do? I need to put in, that's where the formula is. Okay, box plot, formula, then data. So I just need that one. This is when, let's say you are in an organization, you need to check whether the claims from the different districts are significantly different, right? So the data is insurance, then the formula I will say equal to, what do? I want to plot what? Claims as a function of what? Of the district. So claims, and then I copy district, I put it over. The tilde means on. So it's like claims is your Y, and then your X is what? District. So I can do this. So that's it. So district 1, district 2, district 3, district 4. What does this do? It helps you to now compare them, okay, at a go. Okay. So this I can do 2 to 5, and it will color them like this. Okay. So what can you say about this? Well, if you look at it, the group 4, they have the least claims, right? Because their numbers are very low. What is an outlier in group 4 may not be an outlier in group 1. Is everybody okay with this? Now, if you were,
you can see it clearly.
Yeah, if you were to compare this, right, this is where you use, let's say, an ANOVA. But remember, because of the outliers, they may not satisfy your normality assumption under an ANOVA test. So you may use some non-parametric tests like the Krukskaya-Wallis test and so forth. So here, we can compare the districts at a go. And we see that each of the districts has unusually 2 large observations. If you take the 4th, these 2 are outliers. If you take the 3rd, these 2 are outliers. You take this one, these 2 are outliers. So that's the beauty of this box plot, that it helps you to, be able to do some of these things quite easily. Okay, and if you remember, there's also stem and leaf, so I can end here. Stem and leaf, if you remember this. Now they even teach it at class 5. Okay, so that in R is just stem. So I can, let's say, do the insurance claims. Stem and leaf is just like a histogram. So, but that R does not treat it as a graph. Okay, now it comes like this. So you see, but this is also like the histogram. If you draw a box around the numbers, you get a histogram. So it's just the same as what we got from the histogram. Okay, so that's it with this plot. I'll make the videos available. Please make sure you take your time. As I said, don't watch it like you are watching a video, but practice as you can. Okay, so that will be it for today. Can we meet tomorrow?
Ciao, please, no, we have accounting. We have accounting at that time.
Online in the evening.
In the evening?
Yes.
So please, let's do this next week.
The life insurance.
Life insurance.
You have.
In the evening.
Please, let's do tomorrow.
Oh,
Please, let's do tomorrow. They're talking about
There's what?
Doc, we will schedule a meeting for you next week, please.
Class rep has spoken. Okay, so we are a bit behind. I wish like this weekend, maybe Sunday if you can, so that I can finish with the basis, and then from next week you can be doing what really we should be doing in actuarial science. So if you can, please schedule, even if it's 1 hour on Sunday evening. Is that okay?
Sunday, our lectures ends at 7:30.
Then next week you won't get time.
In the week, not necessarily in the weekend,
okay.
but in the
so
week.
please think of it when you get the day. Just let me know.
Yes,
maybe
please.
7 to 8 or whatever time is okay for you. You let me know.
Okay, sir.
All right, because I want to finish with this, talk about functions, and then we can then move on to the actuarial concept. But please, I'll send you the video. Please take your time and go through it. Make sure you can do these things on your own. Okay, thank you.
Yes, sir.
And have a nice weekend.
Yes, sir.
Yeah, take care. Bye-bye.